I guess the first thing you'd say is like a large shipping container. There's a lot more goes on behind the scenes as far as development, design and labour to get that effect, I guess.
It's just steel with a few different elements and a few different compounds in it, or alloys, to give it the special weathering characteristics. Our design component of our work is simply to try and understand or guess or interpret what the engineers and architects' vision is and bring that to reality. So what happens on that steel is it rusts, it creates a patina of rust which then acts as a protective layer to prevent further corrosion. So what you're seeing is rust, but the rust, once it creates, then decelerates, so you're just seeing what is a protective coating of rust. Feedstock comes in a 1200 wide coil. That's the standard width that BlueScope make it. So we designed something that was the most efficient way to use a 600 wide section of coil, 600 being half of 1200 and 600 being something that can be handled readily, safely by a man. We came up in conjunction with the architect and Bates Smart this inverted top hat profile, which is then fixed through a vapor barrier, fixed directly to a batten or structural steel substrate. We fix it in through the valley, so the idea of the wide panel and the narrow rebate was just to try and disguise the fixing.
On this project we had to develop a way to make this facade waterproof, and we did that by double backed foam between the lapping joints. So you would put a panel on there, you'd lay the foam up the middle strip before you lay the next panel on there. That will filter out the water that way, and then if any water did get in, we've got the Z flashing at each level to break that up.
Installing itself was no mean feat because we had to work off scaffolds, we had to work off boom lifts, we had to work at height, we had to get the material up onto the scaffold, we had to manhandle it into place and fix it off. And that was all on top of the structure which we built. Pretty much half the contract value was the structure supporting the cladding. So we see this wonderful cladding on the building, but we're only seeing half the story.
One of the problems we're faced with where we have the Z flashings at each level, to try and keep that line between each level straight. So if you could imagine one level might creep ahead the other level, then all of a sudden your lines don't line up. So it's quite labour intensive getting that right. Off the side of the scaffolding we had the glass suction caps, what they use to install glazing and stuff, and that's how we held the panels up there, hold them in situ before we screwed them off. The hardest part on that project would have been the eave. If you could imagine you've got a 60 or 70 kilo sheet you're trying to hold above your head to fix it off, plus you've got to try and get all your straight lines.
That's the number one difficulty we have in any project, is interpreting and bringing the architects and the engineers' dreams into life.